In our previous video, we learned that force has both magnitude and direction. Magnitude is the numeric value and direction of force is the direction in which the force is acting. We had taken this example where the force of magnitude 5 newtons was acting on the desk in the east direction and then the force of magnitude 10 newtons was acting in the northwest direction. Note that Newton is denoted by N and it is a unit of force. But can there be more than one force acting on an object? Yes. In fact, in almost all of the examples that we come across, there is always more than one force acting on the objects. Also, the forces may act in different directions. So how will an object behave if there are many forces acting on it? Let us find out. Take this stationary object for instance. There is a 10 newtons force acting on it in the upward direction and a 10 newtons force acting on it in the downward direction. Is the object moving? If yes, then in which direction is it moving? The answer is that it's going nowhere. We see that there is more than one force acting on the object. The two forces that are acting on the object are equal in magnitude. What about their directions? One force is acting in the downward direction and the other is acting in the upward direction. So both the forces are opposite to each other. So we can say that this object is under the influence of equal and opposite forces. The object is not moving because these equal and opposite forces cancel each other out. As the forces cancel each other out, we say that the forces are balanced and the net force on the object is 0. Now look at the second object. There is a 15 Newton force acting on it in the upward direction and a 20 Newton force acting on it in the downward direction. Are the forces balanced here? No, they're unbalanced because they don't cancel each other out. The net force here will not be 0. Can you guess what the net force will be here? Yes, it will be 5 newtons downwards. 20 minus 15 is 5 and as the downward force is more in magnitude, the net force will be 5 newtons downwards. That's where the object will move, downwards. This tells us that if the two forces act in opposite directions on an object, the net force acting on it will be the difference between the two forces. For the first object, both the forces had a magnitude of 10 newtons and they were acting in opposite directions. The net force on the object was 10 minus 10, that is 0. Now let's look at another example. Look at this image now and try to find the net force acting on this object. In this case too, there are two forces acting on the object. But this time, the forces are acting in the same direction. The net force in this case will be 15 newtons upwards. Forces applied on an object in the same direction add to one another. Here is an example of this. Suppose that you want to move a pretty heavy load and you alone are not able to move it. What would you do? You'd ask for help, right? So you and your friend together move the load easily. What is the reason for this? Here, two forces were acting on the desk, yours and your friend's, and both the forces were acting in the same direction. Both the forces combined together to produce a greater net force. Remember, if two forces are acting on the same object in opposite directions, then the net force on the object will be the difference in the two forces. And if the two forces acting on the same object in the same direction, then the net force on the object will be the sum of the two forces.